Let's do some weird ones that we have to see a few times to make sense of. But once you see it, you mess around with it a few times, I think it becomes pretty clear. With this initial, I like throwing this up at my Calc 1 students, like right off the bat. I mean, like, yeah, dude, go ahead. Just go find cosine of sine inverse of a half plus cosine inverse of 1. Be like, go get that answer. I'm telling you, more than 9 out of 10 Calc 1 students look at that. I don't know what to do. And that made me sad. So now I'm kind of a dick about it. And I like to make sure that you know it, because you'll eventually be dealing with stuff that looks just like this, but with like an application and doing things with it. And I hope you don't have to struggle with this part once you get there, because you pick up the pattern. Let me shut my mouth and start getting towards teaching or showing you what's going on with it. So when you get a bunch of nonsense, anytime, say it's been, if you can just remember this one piece, it's been a year or something, you go and you get into your math class and you're like, oh no, I see it. And you're like, wait a second. That weirdo was always talking about what are inverses? They're angles. Just keep that in your head. When you get stuck and there's a ton of stuff, just be like, what are inverses? They're frickin' angles. That's an angle. Like alpha, maybe? That's an angle. Like beta? So we just have a sum formula here. It's funky and it's hidden and it's weird. That's all that's happening. We have two angles that we're adding up. And for this particular problem, we don't need to use a sum formula, because we can evaluate sine inverse of a half. We can evaluate cosine inverse of 1. Sine inverse of a half? Sine inverse of a half, well, that's just equal to pi over 6, or 30 degrees. Cosine inverse of 1, that's that tricky one. I'm telling you, cosine inverse is just a jerk. It just doesn't behave nicely. And cosine, I get this one backwards. Like, I'm buying my time to make sure that I'm going to say it right. And yes, cosine inverse of 1 is 0. Right? What's cosine inverse of 0? You know what I mean? It's weird. It's pi over 2, by the way. Oh, let me get my equal sign in there. Logical progression. So we have cosine of pi over 6 is all we have. The exact value of that is root 3 over 2. Spectacular. There it is. So that's not how we're going to play the game. But at least get you an intro to see this is what's happening. That's what those pictures mean. Because I know this class is overwhelming with notation. From where you start to where you end up, it's a lot. So try and find them patterns until you really got it down. Now this is a good test level problem. I like this. If you look at any model exams, you'll find a problem just like this on every single exam too. It's this game where, unlike the first one, I'm not sure what alpha is. I'm not sure what that angle is. At least I don't know it exactly. I can draw the triangle that has an opposite of 12 and an adjacent of 5. I can do that. Sine inverse of -4/5, that angle, that beta that's hanging out right there, I don't know the exact value of it. But I do know you can make a triangle in the 4th quadrant, since that input's negative. You make a triangle down in the 4th quadrant, and I can describe the triangle to you. Because what does sine pop out? If this was just like sine of, I don't know, I'm going to pick something random. This 3 pi over 4. It's equal to root 2 over 2. So it'd be a ratio, right? We're looking for, our answer is going to be a ratio. Just like these. We never have to find the angle. We just need to figure out what these frickin' ratios are. So, enough lead in. Let's go. Let's play the game. So let's start off by doing this, acknowledging that this is alpha and this is beta, by actually setting them equal. Let's go aside, go like alpha, and get rid of this little equal sign there. I'm going to go an equal sign down. All right, so alpha will set equal to tangent inverse of 12 over 5. And we're going to set beta equal to sine inverse of -4/5. Cool. I just wanted to set that aside because we're going to replace it now. Well, right here. Let's just go through and be like, well, now we have sine of alpha plus beta. So this is equal to sine, cosine, cosine, sine. Sine does keep the same sign. It goes alphabetically. And what this is doing is telling we just need to find 4 values. We need to find what the heck is sine of alpha. What the heck is sine of alpha? What's cosine of alpha? What's cosine of beta? What's sine of beta? But we have info. We have info. In blue, there's the info on your alphas. That triangle, make a freaking triangle and go find out what sine of that triangle is. Make the triangle, find out what the freaking cosine of that one is. You do the same thing with beta. So let's go. I'm just going to jump aside. We're going to make some triangles here. Just going to draw the triangles for these 2 angles. Alpha, if the input's positive ever in an inverse, you're in the first quadrant, okay? So let's make a triangle in the first quadrant that has an opposite of 12 and an adjacent of 5. That's a 5, 12, 13 triangle. I'm just going to put the 13 in there. And there's angle alpha. Dude, what's sine of alpha? Isn't that the opposite, 12, over that 13? What's cosine of alpha? That's the adjacent, 5 over 13, the hypotenuse. We run on back and let's just punch it in. Sine of alpha is 12 over 13. Cosine of beta is 5 over 13. Dude, now we just got to play the game here. And that one's even easier. It gives us to us in sine inverse. I wonder what sine of beta could be. I mean, I just wonder what sine of beta could possibly be when we hit that thing on a sine on both sides. Let's go. So we could hit this thing with a sine on both sides and you get your answer. Or we could just kind of stick to the game and don't forget we're dealing with inverses so we don't put something in the wrong quadrant. So let's look back here. Remember that sine inverse, it can only be between that beta, that angle. Dude, we know for certainty that this needs to be between 0 and pi. Oh no, that's cosine inverse. I made a mistake. Sine inverse is negative pi over 2 to pi over 2. So you can only be in these 2 quadrants. Since our input is negative, we sure as hell can't be in the first quadrant. Therefore, we must be in the fourth quadrant. This works for tangent inverse and for sine inverse. If you have cosine inverse and it's negative, you'll be in the second quadrant. So let's draw our triangle in the fourth quadrant. Coming out of here, we're saying that this is beta. All right. So our opposite is -4, and that makes sense. It's down here. Like if you were to accidentally draw your triangle over here and you put -4 up there, wouldn't that seem silly? Wouldn't that seem wrong up in the positive y values? Yeah, it helps you to know. So when you jack it up with sine inverse or cosine inverse and you put it in the fourth on accident, look at your freaking signs. It'll tell you you're making a mistake. And then we have the dark. Hypotenuse is 5. So this is a 3, 4, 5 triangle. I'm using angles or triangles you should already know, and that's going to be positive because this is in the positive x direction. So we can go find the sine of beta. I mean, we already knew it was -4/5 just by looking at the problem. But cosine of beta is going to be our adjacent over our hypotenuse for 3/5. Let's go. Let's go plug that stuff in. Let's put it all together, and let's be done with this dang problem. So we put our 3/5 right here, and we put our -4/5 over here. Number one mistake on this for students that are prepared and know what they're doing, sign error. It's not putting them in the right quadrant and ignoring the signs. The number one mistake is people not knowing what the hell to do at all. But badass students like you that are going to get in your practice right now, beware the sign error. So both of these have a denominator of 65. So 12 times 3 is 36. 5 times the -4, I'm going to bring that negative to the outside. Put it over 65. That nice little common denominator. I think that leaves us with 16 over 65 for our final answer there. Yeah, dude. Those are a lot. Those are a lot. Hey, I'd take a look at this problem. I don't know. Take a look at it. I'm not going to solve it. I'm not going to solve it. Maybe just do this for you. But I don't know. Take a look at it. It might be important or something, but maybe not. I don't know. What do I know? See you soon.